Hi, it's Mr. Crane here, and I'm coming to you to kind of give you a little piece of information about the lab that you're going to be conducting. So this is the lab for tomorrow. Those of you that this is more for virtual, I'll tell the face-to-face students what I need to tell them tomorrow. But this is for virtual students. So this is your lab document for tomorrow. What you will need to do is come up to school, to the office, and pick up a bag like this. You will tell your teacher whether or not, or your Miss Hughes, the secretary, or Mr. Unger, whoever's in the office at the time, that you want either a bag of M&Ms or Skittles. So you choose. If you're not a chocolate fan, or you're maybe worried about a peanut allergy or something like that, then pick the Skittles. All right. So this bag has an unknown number of either M&Ms or Skittles, has a cup, and then just the plastic bag that's been sealed. I put them in there with a glove on, so they're not worried about contagion or being contagious or anything like that, getting any type of viral impact from exposure. So once you get that, you're going to go home and you're going to open up this document right here that I have in front of me. It says "Get a half-life: radioactive decay and dating." The purpose is to relate the rate of which materials decay. We've been talking about relative dating. We've also been talking about absolute dating. Absolute dating uses carbon 14, uses uranium 238, rubidium, and cesium, several elements that undergo radioactive decay or breakdown from the parent, the original element, into a new element called the daughter element. And we're going to convey this understanding of half-lives in this lab. So directions, a decay function is one in which the values decrease by a constant factor, but it is not linear. These functions are often used to model the decay of a radioactive element. The half-life of a substance is the time it takes to reduce its initial effectiveness by one half. Geologists have been able to date the age of Earth by using rock samples and charting the radioactive decay. I gave you a video by Mr. Anderson on radioactive decay. It was pretty in depth. Towards the end, it was more high school level, but it just talked about how something becomes something else. But for instance, how uranium can give off a proton and become thorium. So in the PowerPoint that I gave you, you learn that carbon 12, when it decays 5,730 years later, decays into nitrogen 14. So carbon 14, the isotope, becomes nitrogen 14. So today we're going to take an M&M and a few Skittles. So it'll be Skittles, S&S instead of M&Ms. And one of the Skittles or M&M has a side that's up where the M is showing. That's M side up. Or M side down would be the M, the symbol on the M&M is not showing. If you're using Skittles, it'd be S side down or S side up. So you're going to follow this direction. You are not to eat anything until the lab tells you to do so. Make sure you're eating the correct one. So do not eat anything until after you've conducted the lab, and chart your progress with this particular chart here. So my advice to you is to take the Word document, convert it to a Google document so that it's saved. And then when you upload it, you're going to upload it. You're going to download that document as a PDF and then upload that back into Moodle. So you're going to pour out the M&Ms and count your beginning sample size. That's your sample size in. This will be your N value when trial number is equal to 0. So right here is a 0. It says decayed atoms inside up. You're going to total up your number and see how many total you have. That's 100% of your sample. So you could have 40, you could have 20, you could have 30, whatever. It does not matter. You're going to then you're going to shake up the cup gently, pour out the M&Ms out back on a paper plate or napkin, whatever. Remove all the M&Ms with the M side showing. So basically, you're going to separate them. You're going to sort them, M side and no M side, or S and no S. You're going to sort them and you're going to count them. And then you're going to put those totals right here. And then I will teach you how to get the percent remaining. So we'll have to do some math, but I'll show you that in a different video, not on this one. And next week we're going to graph it. We're going to graph it on this, but if you choose to graph it on this because you don't want to use a Google sheet that I show you how to use, and that's your choice. Then you have some questions to answer, and then you have this chart to look at and a couple questions. 6 questions total. The whole thing's worth 30 points. So do not hesitate to start. Make sure you come up and get your sample from the office and begin whenever you get it. All right. Have a good day.